Hello to everyone. Today I will be discussing the vibrational structure of electronic band system in emission spectroscopy. An electronic transition involves a change in all three electronic, vibrational and rotational energies of the molecule. Their wave number arises from the electronic transition is given by mu is equal to T of E minus T of E double prime plus Z of prime minus Z of double prime plus F of single prime of F of double prime. This is my rotational energy change, this is vibrational, and this is my electronic. Now this TE prime minus TE double prime, suppose this is the V nu of E, that is the electronic transitions. It's a constant for a given molecule, electronic transition. Z and Z double prime corresponds to the vibrational levels associated with the different electronic states, and so have a different this omega E, equilibrium frequency, and this enharmonicity XE bar. So this new single prime is defined for the vibrational energy levels of upper electronic state, and this nu double prime are the vibrational energy states for the lower electronic states. And similarly, if I would represent this rotational states over here, then I have to represent this F prime, F double prime are the rotational states for the lower electronic state, and the F double prime for the F single prime for the upper electronic states. Or Z and Z may be larger, or this Z prime may be larger and the smaller to the Z double prime. We'll see that if you remember in the case of our rotational vibrational spectroscopy, there itself this delta J is equal to plus minus. You have both the values. You may have this higher this J prime is maybe the higher to this J double prime, or J prime is less than to the J double prime. In a similar fashion, we could say that this J prime may be the higher or the lower as compared to this J double prime. Now, so we are ignoring that the rotational levels structure for the individual band, for that this F prime is equal to F double prime is equal to 0. And this is 0. So we are looking that ignore the rotational structure of individual bands. So now what I could write, so thus the wave number corresponding to the band origins of a system is given by this nu naught is equal to nu electronics, this T E prime minus T E double prime, that nu of E, plus Z prime of nu minus Z double prime of this nu, and simply you have this, we know that this, what is this Z nu, you have simply omega E prime nu prime plus of half minus omega E prime X E prime and nu prime plus of half its square minus omega E double prime and nu double prime plus of half minus omega E double prime X E double prime and nu double prime plus of half and its square. Now for the lower one, because Z double prime, it means that corresponding to this you have a equilibrium frequency for this state will be different for the upper state because your potential is changing. In a previous class, I have discussed about that the enharmonicity of the different electronic state would be the different. So here I am representing this omega E prime and X E prime, and for his omega E double prime and X E double prime. So for the electronic transition, there is no restriction of the change in the vibrational quantum number. It means that this nu is a unrestricted. because you have two independent electronic states where you have a different vibrational state. So this delta nu is unrestricted. So what will happen? The principal transition from each vibrational level of an upper electronic state can take place at each of the vibrational level of the lower electronic state, although the intensity of the transition depending on the population of this nu prime and the nu double prime. Means unrestricted, it means that what I am saying that the transition may take place from the every level to the all level of this vibrational level of the lower state and the every level of the upper state. So that is why this G prime and the G prime may be higher than to this one or the lower to that one. So now this band intensity is depending on the population of this V nu and the nu double prime. So what will happen that if it can take all sorts of the transition from the each level of vibration level of the upper state to the each vibration level of the lower state of this electronic state, then what we could expect that a large number of bands from a single electronic transition. Once you have a single electronic transition, we have a large number of the bands. So as a room temperature, if the temperature is slightly higher than the room temperature, then what will happen is there is a good number of high vibrational level are also well populated. Then you have a sufficient band will be appearing for the same electronic transitions. So some of the transitions, emission transitions, are shown in this figure. Now these are the lower electronic state. It is a higher energy state. When delta nu is equal to +1, then delta nu is equal to +1, then the transition 0 to 1, 1 to 2, 3 to 4. Now if delta nu is equal to 0, then you have 0 to 0 transition, 1 to 1 transition, 2 to 2 transition, 3 to 3 transition, and 4 to 4 transition. And if delta nu is equal to -1, as I said that this may be higher and lower, then in this case, then you have 1 to 0, that is the -1, then this 1 to 2, 3 to 2 to 3, and 2 to 3. Okay, somewhere here I mistake. This is up to here. Then 3 to 4. Now if transitions taking place of this 0 to 2, 1 to 3, and 2 to 4, then delta nu is equal to -2. These are some of the bands because all the transitions are taking place. So in order to analyze these transitions, bands, in a wave number of a band origins are arranged into the energy between the values of nu prime and nu double prime. So once I have to analyze these bands, so we have to arrange these bands with respect to the value of nu prime and nu double prime. So this is the band structure for the corresponding delta nu is equal to +1, delta nu is equal to 0, delta nu is equal to -1, and delta nu is equal to -2. And these are two independent electronic states, and a transition may take place for all these states independently. And even in the previous class, I said that if you have the transition from the single level to the all level to this lower energy level, then it is a nu double prime progression. And if the single vibration level is taking the transitions to the all levels of this upper energy states, then you have a nu prime progression. So once we have to analyze these spectra, these bands, then with corresponding to the value of nu prime and the nu prime, double prime, and this is defined by these Dislandry tables. So this table I am making now with the help of these transition formulas, that is called this Dislandry table. So what you have nu prime and nu double prime. These are the values. So once it is a 0, 1, 2, and so on. So the value of nu prime is defined in this one, and you have this 0, 1, 2, these are the values of nu double prime and so on. So what will happen? Now put the value of nu prime in that relation. You will be getting this nu of E plus z prime of 0 minus of z double prime of 0. This is 1. This is nu of E plus z double prime of 0 minus of z double prime of 1. And once you are putting the value of these two, this nu of E z prime of 0 minus z double prime of 2 and so on. Here this nu of E plus z prime of, because this nu prime is 1, so this is z double prime of 0, nu of E plus z prime of 1 minus z double prime of 1, and this nu of E plus of z prime of 1 minus z double prime of 2. Similarly, this nu of E plus z double single prime of 2 minus z double prime of 0, and nu of E plus z prime of 2 minus z double prime of 1, and nu of E plus z single prime of 2 minus z double prime of 2. This is called the Dislandry table, and you may have all the higher values, and similarly in this fashion. So the comparison of the table with each energy level diagram shows that the constant separation between the two successive rows of the table is the separation. The constant separation between two successive rows of the table of the separation between the corresponding vibration level called the vibrational quantum number. So if you have a successive difference between this and this, 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 so these are showing these the vibrational bands called the vibrational quanta of the upper electronic state. So once there is a transition taking place in between this one, this row and this row, this is a 0, 0, then this is a transition between this and this, because G prime having the different values 0 and 1, then you have a upper state. This is again an upper state. Now once the successive two columns, then in this case the Z nu 0 is G nu is 0, nu prime is 0, but nu double prime is 1 over here, and this is 0. So this is each column it is providing you the successive vibrational quanta for the lower states. If taking the rows in this fashion, then you have a upper energy state. If I am taking the column by column, then you have the lower energy states. So now what I could write now, so now this delta Z prime of half is equal to Z1 of 1 minus of Z prime of 0. Two successive one, that is the rows 1 is equal to, what I will get is, this is 0, then simply put that is omega E minus of XE omega E, right? So simply this G nu, it means that this omega E prime of nu is a 1 plus of 2 minus omega E prime X E prime 1 plus of 1 upon 2 its square minus omega E prime, that is the 0, then is 1 upon 2, then minus this plus this omega E prime and X E prime 0, this is 1 upon 2 its square. Then simply you have this omega E prime, this cancels out, then plus omega E prime X E prime of 1 upon 4 minus omega E prime X E prime, how much? 9 upon 4. Simply then you have this, then this complete, this is 8 upon 4, that is 2, simply this omega e prime minus of 2 omega e x e prime. So once we are taking that this vertical transitions, then you have this energy difference. Similarly, you could write this delta z prime of 3 by 2 is equal to z prime of 2 minus z prime of 1. Then you have this omega e prime minus of 4 omega e prime and x e prime. Similarly, I could write this delta z of 5 by 2 is equal to z prime of 3 minus z prime of 2 is equal to omega e prime minus of 6 omega e prime and x e prime, and so on. So the second differences of successive vibrational quanta of the same and gives the vibrational constant omega e x e. So that is an enharmonicity constant for a upper state. Means there is a second difference between this one. Once you have a second difference between this one, then you have delta 2 of z prime is equal to 2 omega e prime and x e prime. Means the difference between these second difference between their energy states are this, simply this minus this minus this, simply you have a 2 omega e and x e prime. So this provides you the enharmonicity constant for that upper energy level. And similarly, once you are taking the successive columns, what I will get? And simply, now this delta z of 1 upon 2 double prime is equal to this z double prime of 1 minus z double prime of 0, and similarly this omega e double prime minus 2 omega e double prime of x e double prime, and delta z of 3 by 2 double prime is equal to 2 minus z double prime of 1 is equal to omega e double prime minus 4 of omega e double prime and x e double prime, and a similar fashion delta z of 5 by 2 is equal to double prime of 3 minus z double prime of 2 is equal to omega e double prime minus 6 omega e prime and x e double prime. Again, the second difference between these are these bands for the transition between the lower energy levels. So similarly, the constant separation between the two successive columns between the corresponding vibrational level of the lower electronic state are represented by this in this fashion. So from here again, now the second difference for this delta 2 of z double prime, you have this 2 of omega e double prime x e double prime, where this term is the vibrational constant for the lower electronic state, vibrational constant for the lower energy state. Now from the vibrational equations of the each electronic state, so what we could write from this relation, now what we have, this omega e double prime is equal to, we have delta z of 1 upon 2 double prime plus of 2 omega e x e. And similarly, from the previous relation, that from the higher one, we have this omega e single prime is equal to delta z of single prime 1 upon 2 plus of 2 omega e prime and x e prime. So it is seen that we can see that from the energy diagrams, band system can be divided in a number of easily recognized groups, each group consisting of few close bands. These are called the sequences. Delta nu is constant. This is delta nu is equal to constant. Delta nu is equal to constant. That is the sequences. And the bands of the sequence lie along the line parallel to the diagonal of the dysentery table. So in the previous table, if you look at again that table, so now once you have to check the sequences, once I said that you have a transition in a row wise, in a consecutive row, then it is giving the transitions for the upper energy level, electronic level, and once you are going to the column wise, then you have a transition for the lower energy levels, electronic states. Now the transitions you are taking, now the sequence you are looking at once you are going to the diagonal one. So you have both the transitions, that is lower energy state as well as the higher energy states. How it is? Because in that table, if you remember, we wrote this is 0, 1, 2 and so on. This is the new double prime and this is new prime. This is 0. Then you have simply this new E plus of Z prime of 0 minus of Z prime of 0, G double prime of 0. Then you have this new E plus of Z prime of minus Z double prime of 1. Then for the 2, then similarly you have this new E plus new 0 of minus Z double prime of 2. And here you have this 1, so you have this new E plus Z prime of 1 minus Z double prime of 0, and new E plus of Z prime of 1 minus Z double prime of 1. Then you have new E plus of Z of 2 of Z double prime of 2. So once I am either going to the diagonally, means the transitions is 0, 1, 0 and 1. Similarly, you will have here new plus of Z prime of 2 minus Z double prime of 2. Then you have a transition this Z prime of 1 and Z prime of 2. Either I am going to this diagonally or parallel to the diagonally. Parallel to the diagonally means either I am going this fashion, in this fashion now. So here you will be having that new of E Z prime of 2 minus Z double prime of 1. Now either I am going to diagonally, parallel to diagonal in this fashion. Now here the transition is 0 to 1 and 1 to 2. Here you have this 1 to 2, 0 to 2. These are the progressions. So diagonally of the disciplinary table, bonds in the horizontal rows and the vertical columns from this new double prime and the new prime progression respectively. So you have this new prime progression diagonal to this one bands, that is the horizontal rows and the vertical columns. So once you are doing the horizontal rows, you have this new double prime progression. Once you have a vertical one, you have a new prime progressions. So this is all about the electronic vibrational spectra. And this is very complicated, as I said in the previous class that it is more complicated as we have this vibrational rotator. So today I will be stopping here, and tomorrow I will discuss about the electronic band spectra in absorption. This is the emission. Now I will discuss about in absorption. Thank you.